Okay, for number 13, I switched these around accidentally, so you're going to forgive me. 13's right here and 14's right here. So we're going to start with 13, and we're going to, I like to write down the formula first so I know what I'm using. So I'm going to use the formula arc length. I do the proportion one. I don't know what your teacher does, but I do arc length over circumference equals the measure of the arc over 360. Whoa. So for number 13, I'm going to set up my proportion. I'm going to fill in what I know. So my arc length is 21, which is right here. That's 21. So I put that in on top. My arc length, and it's arc length part over the whole. So on the bottom would be my circumference. And I know the formula for circumference is 2 pi r. And I'm going to use 2 pi r instead of c for circumference because I'm trying to find the radius. So I'm going to put 2 pi, and I don't know my r, that's what I'm trying to figure out, so I put r there. And then on this side of the equation, I'm doing my measures. So I have to do the part of the measure over the whole measure. So it's going to be 73 over 360. And when I do this, I cross multiply. So I'm going to take these two, multiply those two together. And when I do that, I get 7,560 equals, and then when I multiply these two together, I get 146 pi r. I don't multiply out the pi because that makes it a messy number, so I keep it as pi. So 146 pi. I need to divide by 146 pi to get r alone. So that'll cancel. And when I do that and put in the calculator, I get an answer of 16 and 48 hundredths. So my radius is 16 and 48 hundredths units, because it doesn't give me. Alright, so now I'm going back to number 14 on top, and I'm going to use the same formula that I did before. So I'm trying to find, it's asking me for the length of AB, so I'm looking for that. So I am going to put X here because that's where the length goes, over the, so that part over the whole circumference. I'm going to put an X here so we know what we're finding. Circumference I know is 2 pi r, 2 pi, and I know my r is 42 right here, so I'm going to put 42 in there, equals my arc measure, which is 85 over 360. I can do the fish hook, or I can just cross multiply. When I cross multiply, I get 360 pi, or sorry, not pi, but x, equals, and then I multiply all of this together. I'm just going to multiply my numbers. So 2 times 42 times 85 gives me an answer of 7,140 pi. And I need to divide by 360 because I'm trying to get x alone. And when I divide 7,140 pi divided by 360, I get 62. X equals 62 and 31 hundredths if I round to the nearest hundredth. So 62 and 31 hundredths of a unit. Okay, on to number 15. Ooh, it's crunched it all together here, so I'm going to try to write small. I'm going to use the same formula for number 15, so I'm still trying to find the circumference. So I would set it up, and I would say 85. I like to put my degrees over here because that's the easiest for me to find. My arc length is 23, so I put 23 over, and I'm trying to find circumference, so I'm just going to put C or X. I don't have to put 2 pi r because I want to find the whole circumference. I'm not looking for the radius. So I can fish hook it, or I can just cross multiply. multiplying those two and those two, so I have 85C equals 360 times 23, which is 8,280. Divide both sides by 85, and C equals 97 and 41/100. So 97 41/100. Now looking at number 16. Now this is a little different. I'm trying to find the area instead of circumference. So I use the same formula, but instead of circumference, I'm going to put area down here. So I have, again, 60 degrees over 360. I could reduce that if I wanted to, but in order to stay away from mistakes, I just leave it because I'm using a calculator anyway. I want to find the area of the shaded regions, and that is what goes on top. So I want to find this area, and I have to do that, put that part over the whole area of the circle. So I put the area of the shaded, which I don't know, over the area formula, which is pi r squared. Now looking back, I'm going to erase that actually. I'm going to find my r, and I can find my r from here. My diameter is 4, so my my diameter is 8, so my radius equals 4. So I can put a 4 here, and I can even change that to 16, because I know that that 4 squared is 16. That 2 is not going to erase, so I'm just going to write right over it. So I have 16 pi. When I cross multiply, write it over here, 360x equals 60 times 16 pi. And I get an answer, oops, I'm going to keep that pi out of it. I'm just going to say 60 times 16, which is 960. So I'm going to erase that 3. But 960 pi, so my number's not so crazy. Divide by 360 on both sides. So 960 pi divided by 360 equals 8 and 38/100. So x equals 8 and 38/100. Okay, number 17, same idea. I'm going to find the area of the shaded region. And when I did this one, I'm going to move this up so we have a lot of room here. I found the area of the small and the big, and then I had to subtract it out to find the area of just the shaded region. So I'm going to find the area of the big circle first. So I'm going to put B for, well, I'll write big in there. And it's pi r squared is my formula, so pi times the area of the from A to C is 9. So 9 squared is 81. So I'm just going to say 81 pi. And when I figure that out, it equals 254 and 47/100. Then I find the area of the little guy right here. So the small, again, pi r squared. So pi times 4 from A to B is 4, so I can put 4 squared, which is 16. Just going to skip a step there. 16 pi equals 50 and 27/100. Okay, so now I just need to subtract those two to get the area of the shaded. So shaded circle, it's 254 and 47/100 minus 50 and 27/100, which equals 204 and 20/100.